From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
This episode of Fragmented is brought to you by American Express. I'm here to let you know that their Android team is hiring. If you love the idea of working in a team which values testability, customer experience, and proper Android UI design guideline support, all while getting things done right the first time, well then, my friend, keep listening. The Android team at American Express prides themselves on shipping a high-quality experience to end users, all while implementing the latest and greatest technologies at hand. For example, what about Kotlin? Yeah, they've been using it for 2+ years. It's what we write in every single day. Design patterns? Yeah, they got you covered from UI patterns to typical Gang of 4 patterns. They've seen it all and they know when to use the right tool for the right job. Well, what about testing? Like integration, functional, and unit testing, you might be wondering. Ha, you're in luck again. They have a huge test suite that is run at every single PR to ensure that no regressions are hit. Now, those are going to be functional, integration, and unit tests, and so forth. And get this, you're given the time to write the test to ensure your changes don't break anything and ensure your changes work. Yes, you're given the time to write your test. Now, let me go off script here. How many companies are happy that you spend extra time writing tests? Well, probably very few. I can't count many on one hand that have been happy with me spending more time writing tests. They probably wanted to, or you probably wanted to, but you just needed to ship the code faster. Well, American Express, they know that getting things done right the first time matters, and testing is paramount, which means that quality is paramount. Now, maybe that sounds a bit scary because you've not written a ton of tests. Well, you're in luck then, because the team at American Express is full of fantastic folks who will help mold you into becoming the best version of your current self when it comes to developing professional Android apps. And here's another great thing about American Express. They support you for being part of the community. And for example, do you want to speak at conferences? Totally, they support you. You want to build your writing skills on the tech blog at americanexpress.io? Go for it. Again, they support you. What about contributing to open source? Again, they support you. Start writing that open source. If you want to be part of the community in any way, from speaking to coding to running a user group, etc., you guessed it, they'll support you. And finally, they get the whole work-life balance thing. It's not a myth. The benefits are great, and you're not required to work 80-hour weeks. And well, to tell you the truth, that just makes life a lot easier. How can I say this with so much confidence? To tell you the truth, I've been working with American Express for over 2 years now, and I've seen this all firsthand. So if you're interested in coming to work alongside of me, follow the link in the show notes and be sure to tell them that I sent you. I hope to see you around.
Kaushik, how are you doing, man?
I am doing good. How are things your side? I hear there's like a storm there.
Yeah, that's a Hurricane Michael. So I guess when folks hear this here in a couple of weeks, it'll be far and gone by that point. But yeah, it's getting ready to come up to me, but it's actually probably pretty close to our guest here on the show. So that'll be pretty interesting. Hopefully we'll keep our fingers crossed that no power goes out and everything like that. So, but anyway, one thing I wanted to ask you is, have you ever worked with ProGuard that much?
I am very well aware of ProGuard, and I've tried actively always to avoid using ProGuard, just because I've tried to find someone else and make it their problem. I would like the benefits of ProGuard. I just don't like doing the work. So that is my attitude towards ProGuard. What about you?
Yeah, I've had very similar problems to you in regards to ProGuard, and also other tools that I've used in regards to obfuscation. And it kind of leads me to today's show. The guest and I currently work together over at American Express. And anytime I've run into issues in regards to ProGuard, maybe obfuscation, things that I'm doing wrong or things that I should be doing, I usually have to reach out to him to help me solve those things. So without further ado, I would like to welcome Jeb Ware to the show. Welcome to the show, Jeb.
Hey, thanks for having me.
Jeb, for folks now know that you and I work together over at American Express, but for folks that aren't familiar with you or haven't seen your talks at DroidCon Boston or anything like that, can you give us a brief background information on perhaps yourself and your history in Android and so forth?
Sure. I've been doing, so now I'm an Android engineer at American Express. I've been at American Express for 5 years. I've been doing Android since 2009.
Nice.
I bought the G1 when it came out, and I thought, I know Java, right? I could make apps for this. So I started there.
That is a similar story for most people. They're like, oh, you know Java, therefore you are now you are an Android developer.
Yeah, they just was it the 10-year anniversary that just went by of the G1 that came out, right?
Yeah, I got mine out and took a picture of it, booted it up. It still looks wonderful. I still love
Yours
that keyboard.
You're still boots? Mine
Oh yeah.
doesn't. Mine doesn't. I have two of them because my wife had one and I had one, but mine just no longer boot anymore. But yeah, the keyboard was nice. So anyway, Jeb, one of the like I said when we were introducing you here at work, when me and you are working together, a lot of times I have to do something for whatever reason. We have ProGuard configured, and which we'll get into reasons why you want to use it. And I end up having problems with it. And long story short, I end up kind of knocking on your door, sending you a chat message saying, hey, can you help walk me through what I need to do here? Or what does this line of code in this ProGuard rules file do? And so forth. And it seems like you have a pretty good handle on ProGuard. So I'm wondering if you could explain to folks who are listening to the show, maybe like what ProGuard is, why they should care about it, and maybe what's the real benefit of it is.
So ProGuard is an open source tool that runs on Java bytecode and does a couple of things. It does code removal, so unused code. It removes that to shrink your code down. It does obfuscation, which is renaming your code. So from a meaningful name that you're hopefully giving it as a programmer to a meaningless name like A or B, C. And then it does optimizations. So it'll do bytecode optimizations in your Java bytecode.
Oh, that's a nice way. So just to reiterate, there are three primary benefits. One is obviously, like you said, removing like the dead code and like the stuff, the code that's not used. The second is obfuscation, and this is like also like maybe for like privacy, or if you sort of like, well, we can probably talk about that a little later, but code obfuscation.
Yeah.
And the third one is optimization. So these are the three sort of benefits you get from ProGuard.
Yep, and those are the three steps that it runs as it goes through.
Do they run in that particular order?
Yes.
Can you repeat that again, just so we're clear on what is the exact? How do they run it? In what order do they run?
So first thing it does is shrinking. It finds the unused code and removes it, and then it does obfuscation. It renames as much of your code as it can, and then it does optimizations on what's left.
Before we dive into each of these three things, right? I wanted to ask. So, and I know I started this episode saying, hey, ProGuard is like that thing that I never want to deal with. Why exactly is that? Why does ProGuard have a bad rep, so to speak? And like, why is ProGuard that not as easy as it sounds? Because those three benefits that you mentioned sound amazing.
Right.
Yeah. I want obfuscation. I want optimizations. I want my dead code to be removed. But what is it about ProGuard that makes it so gnarly to handle?
So I think the root of the problem is that it's not the thing we're doing all the time, right? We're writing the code. That's our normal thing that we're used to doing, or we're debugging code. We're used to working out how the code works. And then ProGuard tends to be an afterthought, right? You turn it on when you're ready for a release, and all of a sudden something breaks. And now you have this other config syntax that you need to learn. You have these other problems, this whole other set of problems that you're not used to dealing with. And you thought you'd already finished building your feature, but all of a sudden you've got to build something else. You've got to work on something else that you weren't expecting.
So it's almost like just like a case of familiarity with how ProGuard is set up, and like it's just like this different thing that you have to do versus like the regular stuff, is what you're saying?
Yeah, I think so. And then when people see an error, that you end up Googling it, and you end up finding some. I mean, come on, that's what we all do, right? You end up on Stack Overflow. You end up on a GitHub issue somewhere, and you see some really bad advice, typically.
And it's usually some weird thing which we'll get into, like, add this line to your ProGuard file, and you're like, I have no idea what that even means. And that's where the complication sets in. And to me, it feels like one of those things that once you learn it, like you're like, oh, okay, I get it now. And you fix the problem. Most likely you don't see it again for months. You don't run into it again for a long time. And then it happens again. You're like, wow, that is really familiar. I have no idea how to solve this. And then you end up Googling it all over and have to learning it over again. So that's always been my experience.
Yeah, absolutely. I think that's one of the people's stumbling blocks getting into it, is that you use it so infrequently, you just don't remember the things that you learned from the last time you had to deal with it.
Just following up on that. So ProGuard has like a ProGuard rules file, right? Like, I guess my question was like, what language is ProGuard written in? Because it's different, but obviously it's not a language. But the rules file, like, can you tell us like what exactly is that syntax? Because like Don was saying, like, I go to Stack Overflow, I copy paste this snippet of code, and it's so terse, and it looks like this sort of like assembly kind of language. It isn't something that reads as well as like something like Kotlin. What exactly is like the deal with that syntax? Like, do you know?
So I think of that syntax the same as you would for like a command line program. So
I
it's
see.
switches that you're turning off, right? Dash, dash do this, dash don't do that.
Oh,
And so the one you see all the time is dash keep, class something.
keep everything, and then basically
Yeah,
ProGuard is, you might as well not have ProGuard at that point, right?
right. Lots of stars.
Not the stars. So I think before we dive too deep into the ProGuard like optimization, how to use it with like the ProGuard file, I was wondering if we could actually kind of walk through those 3 steps that you had mentioned as ProGuard's, you're kind of explaining to us how exactly ProGuard works, which is probably what you've talked about a lot in your talks and so forth. But it'd be really beneficial here for the listeners to know, like, all right, this is the first step that happens. Can you start walking us through, like, all right, here's step 1, here's what happens, and here's what's happening to the code, here's what ProGuard is doing, etc.
Sure. So the first thing ProGuard does is it reads in those config files, and maybe we'll set that aside and we'll come back to how the config files work.
Yeah.
And then it reads in all your code, right? Because it's going to transform your Java bytecode. So then it matches up the keep rules to the code to find entry points. And this is kind of an important concept, these entry points into your code. So for Android programmers, that's the activities and services and things that are listed in the manifest. That's an entry point where something that ProGuard can't see is going to call into your code, right? You might not have anything that says create new main activity, but the operating system is going to do that for you. So the keep rules point out that entry point where something ProGuard can't see is going to call into your code.
Oh, interesting. Okay.
So once it's figured out the entry points, ProGuard understands how Java bytecode works, right? It understands class references and method references, so it can trace through from there. So it starts at the entry points and starts tracing through, okay, class A calls class B and class B calls class C. And so it can trace through and find all of the code that gets used. And then everything it didn't mark while it was doing that is unused code, right? If you can't get there from any of your entry points, then that code's just not being used, so it can remove it.
And so is that what it does? I mean, is it looking at the actual compiled code, or is it looking at my Java code or Kotlin code?
So it's looking at your compiled code, but it's looking at the Java bytecode, right? It's sort of an intermediate representation. It's not looking at the Dalvik, which is what you're actually going to ship. But it's not looking at your Java and Kotlin source. It's looking at Java bytecode, which is kind of in the middle. But that's important to think about too, because at that point, there's actually not a difference between Java and Kotlin.
Right.
And so ProGuard didn't have to do anything new to work for Kotlin code because it's working on the Java bytecode.
Okay.
But it's also worth noting because that Java bytecode is going to be, especially for Kotlin, it's going to be a little bit different from what you were expecting. The Kotlin compiler is going to change things to make working Java code for you.
Now, this is usually where I feel like, it's taking that shrinking and is this where it removes the code, and how does it remove the code or the bytecode that doesn't need to get used? What's that look like?
So it's read in, Java bytecode, which is class files. And at the end, it's going to write out more Java bytecode, which is class files. So it's just not going to write out the code that it's removed. I don't actually know what the internal representation of that looks like. But, if from its internal structure where it's maintaining all your code, it just pulls out the stuff that's unused.
It's kind of like a black box. Put it in, something else comes out the other side, missing the stuff that you don't need, right?
That's the idea. Yeah.
Oh, interesting. So it's I guess like this also points towards why with ProGuard, what's happening is like the class files are truly different. The final output could be very different from what you originally compiled down.
Yeah. You want it to be different if it's doing anything.
I had a follow-up question to the mechanism that you mentioned. This sounds very similar to like how garbage collection is done. Is that the same idea? Like tracing through and then making sure like there's unused code paths? Like, is it a similar concept?
Yeah, essentially, right? Because with garbage collection, you're starting from, these root things in memory, and then you trace, okay, this object is referencing this one and it's referencing this one. And then anything you don't mark can be garbage collected. That's essentially the same thing as what ProGuard's doing.
Got it. That makes sense. So far, we have talked about code shrinking, which makes sense. The next huge benefit is basically code obfuscation, right?
Right.
Can you tell us a little about the obfuscation process?
Right. So again, ProGuard starts with these entry points, and those can't be renamed, right? Because if the operating system is looking to load main activity, but it's been renamed to A, then you're going to get a class not found exception. So we've got those entry points that can't be renamed, but then everything else pretty much can be renamed. And so it wants to rename as much as possible, because when somebody's trying to reverse engineer your code, you would much rather them be looking at a class called A that implements interface C and has a method B. It's really hard for somebody to figure out what that does. Whereas if you have, hopefully, it's our job as programmers to write code that other people can read and understand, which you want other people on your team to be able to do that, but you don't want somebody outside who's trying to reverse engineer your app to be able to do that.
Now, the obfuscation, does it just do the classes and the method names, or does it also do like variables and stuff too?
It does class member variables. And the compiler itself is actually going to take away the names from like your arguments in a method, or variables that are declared inside a method that have local scope in there. The compiler is going to get rid of those anyway. But for your methods, your member variables, and the class names, that's what ProGuard is going to rename.
But it's also important to note for folks listening that even if you do obfuscate, I mean, someone still has the code. And if they wanted to spend enough time sitting there looking at these weird obfuscated names, they could eventually maybe figure out how something works. But it just makes it exponentially more difficult. Would you agree with that statement?
Absolutely. That's exactly what it does. And I hear that argument a lot, right? Oh, there's no point in obfuscating Java because you're still shipping the whole code, which is true. But if that's what you think, I would encourage you to decompile some code and try and tell me what it does. Because if you look at obfuscated code, it becomes so much more tedious to try to figure out what it's doing.
I completely agree. Yeah, I just had a question that I wanted to go real quick before I forgot it. When we're talking about the shrinking step, it seems to me that, and this is kind of relates back to what the original question is, why does ProGuard kind of had a bad rap? It seems like the shrinking step is kind of what gets most people kind of hung up because it looks like ProGuard is removing something out of your application, but you actually wanted to keep it with that. Is that correct?
Yeah, that can happen.
Okay. All right, so we'll get to that here in a minute when we talk about the ProGuard file. So,
yeah.
And just to reiterate, what is the objective of code obfuscation? Is it purely just to make sure that reverse engineering is made so that we don't like reverse engineer, so that we don't make the app very easy to reverse engineer? Or is there also benefits towards like the size of like somehow the APK or the file going down here?
Yeah, you do get a tiny benefit on size from obfuscation, right? Because the name A is shorter than main activity, but that's pretty minor in comparison to the benefit that you get from removing unused code, which I've seen that remove like half of the code out of a DEX file. Whereas from shrinking the names, you're going to get a tiny little incremental difference.
So you do get, I mean, it sounds like the shrinking has a humongous benefit. I mean, especially with the APK size at the end, right?
Yeah, absolutely. I mean, if the majority of your APK is code, then you're going to see a big difference in your APK size from removing unused code. Especially the more libraries that you've got in, that's typically the code that you're going to remove, right? Because you've thrown in a networking library and an image loading library and a animations library and a logging library. You have all these things, but you're not using all of the features of all of those libraries, right? I might just be doing GET requests. So all the code for puts and multi-part mimes and all of this stuff, that code's never getting hit, so it can get removed and pulled out. So that's the real benefit with code shrinking. It's not like you're writing all this code that you're not using and you need to remove. It's all these libraries that you're including. You're not using all of them. So we can remove the parts of those libraries that you're not using.
I've always felt guilty about pulling a library in that I know that I'm only going to use 2 functions on, but that makes sense. If you still want to pull that in, then you can just use ProGuard to remove the rest of it for you.
Yeah, exactly. So just include every library you think of.
That's the solution.
Compile time. Woo! Yeah. So we have the obfuscation down, and it's going to output, obfuscated code. Everything's kind of mangled. It's still there. It still runs. It's just kind of mangled. Now it looks like we have a last step here, which is optimizations. What kind of optimizations happen at this point?
So this is the part that I know the least about. I'm going to tell you that up front. But what it can do is it can see, if it makes sense to, unroll this loop or just any sort of bytecode level optimizations like that it can do. Or, can I combine these 2, classes with just a static method into one, right? So that it's not 2 classes that have to be instantiated. There's different optimizations like that it can do. I'm not real familiar with them, but I know that they make improvements in performance and efficiency.
There's also at least like in the Java world, like there's inlining that's also like done in certain cases. When you inline code, it's obviously more, it's more beneficial that way. So is that also part of the optimization process?
Yes. Yep. That's the sort of thing that it's doing.
So we have these 3 steps here, and what I'm wondering as a developer is like, what if I really don't care if this app is open source? Maybe I'm creating it, and I don't care about obfuscation. I really don't care about optimizations for whatever reason. But for some reason, I do want shrinking, or maybe vice versa. I do want obfuscation, but I don't care about shrinking. Can I have one of these steps run, or do I have to run all 3 of them, or is this configurable in any manner?
Yep. All 3 steps are independent, and there's a switch for each one. In those, like I said, they're like command line switches. So there's, don't shrink, don't obfuscate, and don't optimize. So you could turn off any one of those steps as you want to.
So I guess it kind of leads us to the point of like this, where are these switches and this stuff set up? Do I set this in my build.gradle file? Is it in another file? I know that there's such thing as a ProGuard rules file, and I've also heard there's a mapping file. So there's a bunch of files that are here involved. Where in this picture does kind of all this configuration happen?
It's your ProGuard rules file. So if you make, if you just say file new project, you'll get one that's called, I think it's called ProGuard-rules.pro or something like that. And then in your Gradle file, you reference that with the ProGuard files directive in Gradle, and then you give it that file name. And so then that tells Gradle is what's actually going to invoke ProGuard for you, and it knows, okay, Gradle, you need to pass this config file into ProGuard when you invoke it.
A fundamental question I had, which I probably should have asked before, is the ProGuard that we see running on Android different from the open source ProGuard that's applicable on Java? Like, is ProGuard tweaked or optimized in any way for Android specifically? Because I do know there's like a ProGuard Android mapping file as well. So can you tell us a little about that?
Yeah, so I think the ProGuard binary itself is the same one that's there from open source. Just Gradle just includes it and invokes it for you. The Android Gradle plugin, that is. But then that Android ProGuard, what is it? ProGuard-Android.text or something. Yeah. So that's a default ProGuard rules file that has a lot of common rules that make sense for most Android apps. So that does things like, that keeps your parcelable implementations, right? Because you got to keep that creator. So there's rules for parcelable, and there's an @keep annotation that you can use in the Android support library. So that file has the rules for the keep annotation, and it has just sort of a list of basic rules that make sense for most Android apps. It has some rules to keep getters and setters on view subclasses, because those could be used for animation callbacks. So it's a really interesting file to go through and look through as an example to see, what are some rules that you might add, and it's useful to look at those and see, okay, why are they keeping this, right? And how can they keep very specifically just the thing they want to keep?
Now this is in the .pro file, right? Instead of the app.
Well, so you've got one in your ProGuard rules.pro, and then in Gradle there's another there's a get default ProGuard file.
So there's one built in already. When I don't have to worry about it all.
Right. So the Android Gradle plugin ships this file of sort of typical rules that you can use. And there's actually 2 versions of that. One of them has optimizations turned on, and one of them has optimizations turned off. So if you want optimizations, you use the -optimize rules file.
Oh, interesting.
Oh, I had no idea that even existed, to tell you the truth. I think this brings a good point. Is inside of this, so we have, let me get this straight. All the Android default stuff comes with it, so it keeps all that view stuff you're talking about. That's already handled for us right out of the box, right?
Mm-hmm.
Okay, cool. So now I'm opening up right now. I'm as we're talking, I opened up an Android project, and I have which is newly created. I have a ProGuard rules file here in it, and everything's commented out. I have things like keep class members, keep attributes, and stuff like that. I was wondering if you could talk about some of the common the common switches that you use to solve most of the problems, and maybe what some of those problems are that you run into.
Yeah, so the problems are mostly around reflection, right? Because ProGuard can understand how, if you have class A that calls B.C, ProGuard sees that. It understands those sort of function calls and class references. It can't always follow reflection. it usually can't follow reflection. If you have a really, really trivial case, it can follow it. If you're saying class dot for name and you give it the whole fully qualified name, it can figure that out. But usually we have something more complex where you're passing in this string that's been constructed, and then you're trying to load that class or load, members on that class, and it gets a little complicated, and ProGuard just can't follow that. So that's where your rules come in, right? Typically, so there's entry points that I mentioned, which is where maybe the operating system is going to call into your code, and then reflection internally within your code that ProGuard just can't follow. Those are the cases where you have to add rules.
So, okay, that makes sense. Makes me kind of think about the next level here. We get a lot of, so we have this ProGuard file already in my application. Now, for whatever reason, I've been following along and listening to various different podcasts, watching different talks, and people are saying, no, hey, you should start breaking apart your application into different modules. And so I have a couple of different, maybe like modules that does X, this thing does Y. Now, for my whole project, do I just need one ProGuard file, or does each module have to have its own ProGuard file?
So you just do one at the end. You put one in your app module, because ProGuard is going to run, once it gets all the code from all those modules together as Java bytecode all together with the app, and it's getting ready to package that, it's going to run ProGuard once at that level. So you don't have to run it for each module individually.
Okay.
If you're shipping a library as an AAR, you can run ProGuard on that on its own, but that's typically, just if you have some internal code that you're trying to hide.
Okay. All right.
So at this point, I've noticed another problem that I've found when using ProGuard is I use a whole bunch of other tools. For example, like Crashlytics, Fabric, Rollbar, like a whole bunch of these other tools that in some ways help me understand. Like say I have like a crash and I open up the crash report, it tells me, hey, this is where it's happening, right? Now, my understanding is if you run it through ProGuard, what happens is obviously because there's a lot of like code that's changed, and this is like the question I'd asked you before, like the actual code that you write when as a developer is sort of changed at the end. The class file is changed. So how exactly do I resolve? Can I just not use the ProGuard? I mean, can I just not use these tools if I use ProGuard? Like, how does that setup work? Can you talk to us about how we can like accommodate this? Because I imagine like everyone's using Fabric and like other tools, right? So how do they handle ProGuard and that combination?
Right. So Fabric, I've worked with Fabric, so I can tell you, Fabric Crashlytics, it just handles it for you. You actually don't have to think about it, because what it does is at build time, it keeps the mapping file that it needs, and we can talk about what the mapping file is maybe later, but it keeps a copy of that mapping file so that when it gets a crash report, and the crash report off the device is going to have this stack trace that's useless, right? It's function a.a was calling b.c was right. So that stack trace doesn't give us what we need to debug the crash,
right?
But it can deobfuscate that using the mapping file and bring that back to your original name, so that you can look that up in your code and see, oh, it was main activity.load whatever.
So during my build process, the ProGuard is run. The ProGuard then outputs a mapping file. And that mapping file gets uploaded to Crashlytics as well, so it can do these transformations, I guess. But what is that mapping file? What's it for?
So the mapping file is a description of what ProGuard did when it did the obfuscation. So for each piece of code, each class member, member variable, each method within the class, it prints you the old name and the new name. So that file is just a long text file, and it'll start, it's class, and then has an arrow, and then, has the new name of the class. Or if it didn't get renamed, it has the old name just repeated. And then for each class, it has each class member in it. So it can be a really long file if you have a lot of code, but it has in there all of the information you need to essentially reverse that process of obfuscation and go from that obfuscated name back to your original name.
So, and this happens automatically for us when you're using something like Crashlytics, right?
Right. Crashlytics keeps a copy of that file so that it can automatically do that deobfuscation, so that by the time you're looking at a crash report, it's already deobfuscated for you. So
it's basically already looked inside. It said, hey, I already got A.B is calling B.C. It looks at the mapping file, says, okay, let me kind of reverse this. It's actually this, Don's main activity called Don's null activity, which blew up for whatever reason because of a null pointer or something like that, right?
Yeah, exactly.
Okay. Now, what if I don't have what if I'm not using crash analytics? What if I'm like cowboy coding, like boom boom, like I'm not using any crash reporting tools at all, and I'm just throwing it all into some log file or something like that, or for whatever reason I'm getting something and I don't have automatic translation. Where can I get this mapping file? Can I get it from my build? Do I need to hold on to it so I can look up these crashes later? And how would I go about doing that?
Yeah, so where I run into this all the time is if you're trying to debug a crash you saw that happened with ProGuard on, right? So you'll turn on ProGuard in your dev build, your debug build, and you'll get that crash, and it's just in logcat there, and it's obfuscated. And so you're thinking, okay, how do I get back? So that mapping file is in your build directory. It's moved around, but I think it's build outputs mapping.
Okay.
So then there's mapping, and there's a couple of other files in there that are also useful. But mapping is typically the one that you'll use the most. It's the one that'll let you deobfuscate a stack trace. So you can kind of do it by hand by, okay, let me find the line that has com.foo.a.b, and then before the arrow that was com.foo.main activity, right? You can do that by hand. There's also a tool that ships with ProGuard that's got a GUI. It's got this awesome Java Swing GUI from 2000. It's sweet. So you can open that up and you drop in a text file with your stack trace, and you drop in the mapping file, and it'll do that all for you. So you don't have to trace it through by hand.
That's kind of cool. I don't even think I've ever fired that thing up. Have you, Kaushik?
No, I haven't. I don't think I ever have. Yeah.
I'd recommend it. It starts off with this animation of the name coming through. It's pretty sweet.
Just to see the tool in all its glory, you would suggest us using. Yeah.
It's worth launching at least once.
That's funny. That's funny.
I've used Rollbar at Instacart. So for folks, what happens is this mapping file that gets dumped, I believe Rollbar gives you an API where you can actually upload your mapping file to Rollbar and say, hey, for this app, this is the mapping file for this version. So I believe they have mechanisms of doing that. And most tools have this. But Jeb was saying, many of these plugins, like the Android plugins that these tools create, sort of kind of account for that right now. So I guess most tools usually do it automatically, but otherwise, if you want to use that funky tool, that's a good place to start.
Yeah, and you should really keep that file for any release that you ship, right? You're probably, hopefully, you're keeping the APK that you built, that you shipped. You should keep that mapping file along with it.
That's a good tip there. So, I mean, if you are using ProGuard, then hey, keep around that mapping file with the APK. So, wherever you're archiving your things, right? All kinds of stuff going on here. We got shrinking, we got obfuscation, we got optimization. Now, for the developers that are listening to this who are maybe not doing any of these things out there, if they wanted to get going with ProGuard to kind of get some of these benefits right out of the gate, what are the quick wins that they can use to kind of give them that 80-20 of hey, here's what's going to give you the most bang for your buck?
Yeah, so it's hard to turn on kind of incrementally just because it wants to transform your whole app. So I think if you were going to try to do it, step by step or piece by piece, maybe try just turning on shrinking to start with, or just turning on obfuscation to start with, so that you're not having to debug both of those at one time.
Okay.
And then once if you've turned on shrinking, measure the difference that it made on your final APK size, right? Because if you can see, oh, hey, I went from 10 megabytes down to 6 megabytes, right? That's a pretty big difference, and that will hopefully motivate you to keep using it, and also help you, if you need to convince somebody higher up on your team, oh, hey, this is something we should spend the time to work on, because here, look at this benefit I'm getting from it.
To shrink, is there a shrink switch, or do you know what it's called? Or is it?
So it's all on by default. So it's on by default. So then if you don't want it, you pass -don't shrink in your ProGuard rules file.
I see. Got it.
Okay. Do I have to provide a asterisk afterwards to say everything, or does it just automatically assume I don't want to shrink anything?
Mm-hmm.
No, so that does the whole mode, right? That whole shrinking step of ProGuard's execution. But then so we didn't talk about keep rules yet. That's where you get into the asterisks of, for this particular class, I need to keep this and this and this. And we can talk about that more if you want.
Yeah, let's talk about that.
Yeah, so that was my question. So you said okay, start off small, like maybe just add obfuscation, add shrinking. How would I see these problems? Like why would I even see a problem, right? Is this something that would happen in runtime? Like I would have this final APK, but I run the app and somehow it just crashes or it blows up. How would that process work? And I imagine like then we get into like the keep rules, like how do you avoid like step aside from that, right? So can you walk us through that process?
So you'll get errors both at build time and at runtime. Build time, obviously, it's easier to see those. You can start to work those out. That's ProGuard saying, hey, I see this. You've got a keep rule for this class, but it's referencing this other thing that doesn't have a keep rule for it. Maybe you need both. So it has some build time validation. Most of the errors you're going to see, especially like this reflection call failed, that stuff's going to happen at runtime, and you'll get a class not found exception or a forget exactly what it is, method not found exception, something like that from reflection. So then when you get one of those, you got to figure out why, right? What is the thing that is trying, what code is trying to reference a class that's not there, and why isn't that class there? It could have been removed, or it could have been just renamed.
And that's kind of going to depend on your application. It's going to change for every app probably, right?
Yeah, it really does. And there's some common classes of things, right? So if you're using, say JSON to do your JSON deserialization, it's going to use reflection to find the class members to deserialize, right? So if you've got, I've got this person class and it has a first name, but if that first name got renamed to A, JSON can't deserialize it, right? It's first name in JSON, but it's A over here in my class, so it can't match that up. So that's when you start adding in keep rules that says, okay, it doesn't look like anything needs to have this, have this member called first name, but in fact, I need that name to stay the same.
And so that's when you throw inside that ProGuard rules, you say -keep, and then do you pass in like a fully qualified name or what?
So there's a couple of different options for -keep. There's, I think, 6 different variants of keep, keep class member names, etc. And then you give it a class specification, which kind of looks like a Java class specification. So it's something like, class, and you can give it the fully qualified name. And you can say, implements parcelable, right? If you want to specify something like that. And then you have an open bracket. And then inside the brackets are any class members that your rule needs to apply to. So let's stick with this JSON example. For this, you just need to make sure that the class member names have the same names, right? That they don't get renamed. But the class can get renamed because JSON doesn't actually use the class for that. And any code that's not being used can still get stripped out. So you would do a keep class member names rule. And then, maybe you would qualify all my models are in this one package. So you would say com.example.models.**. So that would cover all of your classes inside that package. And then inside the brackets, you would say, I just want to keep the member variables. So there's a special syntax where you can say fields in square brackets or angle brackets, I guess. So that'll cover any fields in a class.
I remember this very recently. I think I'd put up a pull request, and you had reviewed some of the code and said, "Hey, you know what? Like this is like almost like too eager. Like you're keeping too much stuff around. Just add this, like I think it was fields or something like that, to kind of just say, hey, just keep the fields. Everything else can be obfuscated." Does that sound about right?
Yeah, so that was actually the same kind of example that we're talking about. That was JSON serialization, right? And so we had a star within the curly braces, so that was matching every variable and every method within the classes that were in, the package that this rule was for. Well, if you've got, say, maybe you have some other classes that aren't for your data classes. So if you've got, your retrofit interfaces in there, for example, those are going to have methods that we don't need to keep the names for. So we don't want our rule to apply to everything. And so all JSON needs is the member variables.
Gotcha.
So we wanted to make sure the rule just applies to those fields. And this is it's kind of a general tip when you're making keep rules, is to keep them as specific as possible. Find just the thing that you're using reflection to find, and make sure your keep rule just applies to that thing.
I imagine is this a possibility? Like, for example, the thing is, we could do it as a package at the package layer, like assuming all your classes are like all your model classes are like in a specific package. But sometimes, like, if you're packaging by feature versus like packaging by layer, then that could be in like a different package name, right? But are there like different ways of like matching? For example, I could say any class that implements like this model interface or something, don't keep like apply these rules for that, or anything that starts with the name model or ends with the name model. Are those different ways of combining and matching those rules?
Yeah, absolutely. So it's however you want to organize your code, that you can make a rule to match it. So if you're going to do it by package, you can do package dot star star, so that'll match anything under that package. You could do, like you said, you could do with a name. So you would say like model star or something, right? Because those stars are just wildcards, right? They're going to match whatever they can. You could implement an interface. So you would say, class star implements my model interface. You could also do it with annotations. So I gave the example earlier of the @keep annotation that ships with the support library. That's going to keep everything in the class if you put it on the class. You could maybe make your own. You could say, at JSON Pojo or something, right? And then you can make a keep rule for, okay, first there's a trick with annotations is that you have to keep the annotation itself. Then you need to keep any class, class star, or hang on, I guess you have to put the annotation first. So you'd say keep class at annotation, and then star star for the class name in your class specification. So that would be how you make your own annotation that can do some sort of specific keep rule.
Oh, interesting. That makes sense.
That's interesting. Yeah. So now so these are all things that you can do inside the rules file. And that's, I could be the don't obfuscate and then don't shrink or whatever that one was and so forth. That's correct, right?
Yeah. Yep. That's all in your rules file.
Is there a way, like for some reason, I need my QA team to test on a version of the app that's almost exactly the same as production, but for some reason I don't want to obfuscate, or I do want to obfuscate. Is there a way that I can kind of trigger these different types of environments based upon the type of build?
Yeah, you can control that from your Gradle file, right? Because Gradle is how you're turning ProGuard on and off.
Okay.
With minify enabled is the switch to turn it on and off. And you can make that different per flavor or per different build type if you want. You can also give it different rules files if you want for your different build types. That gets really, really tricky to maintain. Try not to do that, just because you don't want to add a new rule to your debug ProGuard rules and then forget to add it in release. That would be a lot of trouble.
It seems like there's a lot of focus around the shrinking and things it's going to keep and not keep and so forth, which makes me think, does ProGuard do anything with resources at all? Will it kind of shrink or remove any unused resources?
It doesn't. There's another tool that can do that inside the Android build process, but ProGuard itself is specifically for Java code, and it's not an Android specific tool, so it actually doesn't know about Android resources. It just knows about your Java code.
But there's something inside of the plugin that can do that for me then, right?
There is, and there's a I forget what it is, shrink resources, something like that. Yeah.
Okay.
There's a flag you can turn on to do it.
Yeah, that was a common question in the early days where folks are like, wait, I have minify enabled and I have shrink resources disabled. Does that mean ProGuard is running, or vice versa? That was always a confusion, because in many people's minds, if they look at the primary benefit of ProGuard, they're like, oh yeah, it shrinks stuff. So maybe that's why it's called shrink resources. But you're right. I think, they're two different things, right?
Yeah, they are. And so, maybe we'll talk about R8 towards the end, but R8 is a replacement to ProGuard that's coming. That's going to be a lot more Android specific, and it's going to be able to understand the relationship between your code and your resources and that sort of thing.
Yeah, definitely. But before we hop into that, I do have just another question. I think when I remember seeing something when I would build build with ProGuard, it would output the files, like you said, to put it into, I think it was build outputs mapping or something like that. And then I'd have the mapping file, but there was also something else like seeds that was there and something else. Do you know what those files are actually for?
Yeah, so seeds is the first one it writes out. That's when I said it reads in your code and it reads in all your keep rules and it matches up, okay, this keep rule applies to this class. So So that's one of those entry points that it's going to use when it's figuring out, okay, some code is going to call into here, and I can use this as a starting point to find other code.
Okay.
So those entry points where your keep rules match your code, that's what it writes out as seeds.
Oh, okay. So things that basically kind of like were not obfuscated is basically what it's saying. Like this is where it starts off.
Well, it's really just useful to make sure that your wildcards or whatever you wrote in that keep rule is matching what you're expecting it to match.
Okay. All right, cool.
So the idea is if I look at that seeds file and I find a class there, then I know it's being ProGuarded. If I don't find it there, then it's not ProGuarded. Is that the idea?
It's actually often going to be the opposite.
I think it's the opposite, yeah.
Right. So if it's in the seeds file, it probably can't be renamed or it can't be removed.
Oh, because
one of your keep rules is saying you can't do that. But then mapping, and which we already talked about, and then there's usage, which is the output of the shrinking phase. So all of the code that got removed in the shrinking phase is written out to usage.txt.
Is that file huge?
Hopefully.
Yeah.
Well,
yes. Yeah.
Or maybe not. I mean, yeah, it's just that list of all the code. The one that's huge, there's another file in there called dump, which I think got turned off recently. But it's basically just a text representation of all of the Java bytecode that's getting written out at the end. So text is a lot less efficient than Java, class files. So it's, this thing can be just many megabytes, hundreds of megabytes for a normal sized app. So I told you to keep the mapping file along with your APK. Don't keep the dump file because it's really big.
So I guess at this point, we kind of understand like what ProGuard is. But before we even go into like some of the advances like R8 that you talked about, what are some of like the common gotchas with ProGuard? Like what are some of the problems that you might see with ProGuard? How do we avoid them? Or like what are some things you have to keep in mind when using ProGuard? Can you like run us through some of that?
The biggest problem is that a lot of the times if you find an issue with ProGuard, it's going to be because it's a runtime exception. And so if you don't hit that code path when you're developing, you're not going to see it. And maybe hopefully your QA team hits it, or in the worst case, your users hit it when it's in production. So your goal should be to try to hit as many of those errors as possible in your QA phase, so that they don't go into production. So one thing I would recommend if you're just getting started with it and you're trying to get ProGuard enabled, turn it on for your QA builds, but don't turn it on for production yet. And maybe leave it that way for a couple of releases so that, your QA team is hopefully going through as much of that code as they can, and they'll hit it. They'll hit, if there's some runtime exception, they'll hit it first before you ship that to production.
That makes sense. The other issue that I have heard before is, again, what this is suggesting, and we didn't explicitly point it out, is you typically don't run ProGuard on your development builds. And the reason you don't is because compile times take a big hit, right?
Yeah,
but
exactly.
You do it only on release builds. But, if for some magical reason you think like your development speeds are fast enough, you can turn it on for, well, I mean, I don't even want to suggest that. That's like insane. Like I can't even get myself to finish that sentence. But
yeah, if you think your build times are too fast, please come talk to me. I would love to know what you're doing. But you might, I like to have a switch that I can easily turn it on in my debug builds, because if I do get a report, from my QA team that says, oh, here's this stack trace and that looks like a ProGuard problem, I want to be able to turn it on and then run, and so that I can trigger the same problem, on debug with Studio attached.
Okay, so just for reproduction, basically.
Yeah, that's where it's really useful.
All right, so I think we've covered ProGuard in a lot of detail. What's this thing about R8? Like the first time I heard about R8, the only thing I could think about is Audi's R8, which is like a pretty cool looking car. What exactly is R8, and what's the deal with this thing?
Yeah, and if you search for it, you're gonna want to add Android R8 or something, because if you just search R8, you're gonna get a bunch of ads for an Audi. It's a new tool that Google is creating that's gonna do, basically it's gonna perform the same transformations of your code and achieve the same goals, but it's a tool that's being sort of purpose built for Android apps. So there's a couple of benefits there. So it can read in, it's going to read in all the same code, but it can also read in your resources, right? And understand, these .xml files or whatever that are Android specific kind of resources. It understands those relationships.
Oh, interesting.
So
And then it's tightly linked with the D8, which is the new Dexer. So that whereas ProGuard has to read in Java bytecode and then write out Java bytecode, and then the Dexer has to read in that Java bytecode and write out Dex bytecode or Dalvik bytecode. With R8 and D8, R8 basically it reads in the Java bytecode, it does its transformations, and then it hands that straight off to D8 to do the dexing. So it skips that intermediate step of writing it back out as Java bytecode.
Oh, interesting. And so we would see a huge benefit in terms of like if you're creating our release builds or coming up with our builds, there's potentially a huge benefit that we're going to see in those times. That's when we're going to save the timing, right?
Yeah, it should reduce your build times, for builds where you have, minification on.
I can also imagine if it's built directly for Android, that they're going to be able to detect things that ProGuard can't, such as, we are seeing that you're not using this, JPG file or this XML file or something like that. It's, they could improve the tooling quite a bit since it's purpose built, like you're saying.
Yeah, exactly. And they're also, they've got a little more focus on Kotlin and sort of these newer language features that Kotlin brings in. So whereas ProGuard is really just focused on Java, where Kotlin we're getting a lot of lambdas and these a lot of more anonymous inner classes. Because of that, they can do some optimizations with those so that you don't have hundreds of classes that are all just one lambda each.
That makes sense. That makes sense. So what exactly do I have to do to turn R8 on? Does it replace ProGuard? Like, so what happens to my keep rules and all that kind of stuff? Is that just magically taken care of by R8, or is that something that we, again, have to do for R8?
So it's completely compatible with the keep rules from ProGuard. So all of the work that you've done to figure out, all right, here's the keep rules I need for my app, that work just carries right over. You don't have to build up a new config file or anything.
Oh,
And to turn
fantastic.
it on, there's a switch in your project.properties, I think it is, where you say
R8 enabled
Android,
or something.
yeah,
Yeah.
it's something enable R8 equals true. And that was available starting in 3.2 of the Android Gradle plugin. Presumably at some point in the future, that's going to be on by default, but you can sort of opt into it now for testing.
Ah, interesting. Okay. So this is something, is R8 stable? Do you know?
Well, it's not on by default, so I don't know what version number it's at, but I don't think they've sort of declared it stable and ready to use. I know there are people who are using it in production, like I've heard from people that are using it in production, so you can, but it's not. We haven't hit the point where I think they're ready to turn it on by default for everybody.
Got it. Got it. Okay. That makes sense. All right. So I think I understand what R8 does. I understand that it's like the improvisation over ProGuard. I guess at this point, can you talk to us about some of the resources that you'd like to share with our listeners? For example, say I've never used ProGuard. I'm like, okay, I'm convinced. Jeb has a good point or two about ProGuard. Where would you point people to? Like, where are like some good starting points so they can start understanding ProGuard and start using ProGuard and getting the benefits today?
So there's some docs on the Android developer website that'll kind of get you started and tell you, okay, here's the switch you need to turn on in Gradle. Here's where you add your ProGuard rules. And then as you're trying to figure out those rules, I've found the ProGuard manual to be really useful. They have really good, descriptions of how each switch works, what a class specification is, how you can, how to use the wildcards, how to use, how to reference methods versus member variables, all this stuff. So the ProGuard manual has just a great detail there if you're ever just wondering, why would somebody write this rule? But you can figure out exactly what it's doing there. You could watch my talk from DroidCon Boston, where I talked about, I went through a lot of the stuff that we went through here. I've got visuals for how these processes work, how the different keep rules are different from each other. So hopefully some of those visuals, I'm a visual person. I like to think about it that way. Hopefully that will help other people understand how it works. R8 is an open source project. It's being developed in the open, so you can see, their code is on, I think it's on Google Source. Their issue tracker and their mailing list are both public, so you can just take a look at those if you need. I back in, February, I think, I reported a couple of bugs on R8, and they fixed them in days. The team is really responsive. They're clearly committed to making a really good tool for us. So if you do find something, if you turn it on and try to run it in your builds, and you find something, report a bug. They want to know about it, and they'll fix it really fast.
Interesting. So if I was starting an Android project today, would you think it's just better to start using R8 versus like using ProGuard, or does it not really matter given that they're both compatible?
It shouldn't matter, right? So that compatibility is never as perfect as we want it to be. But if you were, I don't know, that's a good question. I guess you could start with R8 right now. You may as well, right? So you don't have to deal with the transition.
Exactly.
But I will say, if you're starting a new project, turn ProGuard on from the beginning. It's so much easier to do it at the beginning than to turn it on after you're already in production, because you just have to worry about that testing. Like, oh, if I turn ProGuard on, am I going to break something that I don't see in my testing right now? Whereas if you've got it on from the beginning, you're going to see that, right? You're going to hit those things when when you build that new feature. You're going to hit that problem.
That's a good tip.
This has been, I mean, I'm so curious now. I want to go back and like start seeing what the immediate benefits will be, and like if we can tweak these ProGuard files more. So Jeb, if folks have questions or they want to like reach out to you in some way, which would be the best mechanism to do that?
So a carrier pigeon sent to my house is the best thing. No. So I'm on Twitter. I'm on Twitter like the rest of us. I'm at Jeb Stewart on Twitter. And I promise I'm not scary. You can send me messages there, and I'll respond.
Jeb, thank you so much for joining us today. This is great. I'm sure listeners would appreciate it. This is a topic that everyone has always been thinking about, but it's always in that thing that's in our backlog where like if you haven't turned ProGuard already, then it's on someone to do it, and then everyone just keeps avoiding that task. Hopefully, after listening to this episode, most folks would feel a little more encouraged to try ProGuard. And if they have questions, they can always shoot it your way, I guess, right?
Yeah, I don't know if I want to be everyone's designated ProGuard. But yeah, I'll do my best.
All right. Jeb, thank you so much for joining us today.
Thank you.
Thanks, y'all.
Thank you all so much for listening, and we will catch you in the next episode.
Once again, we'd like to thank American Express for sponsoring today's episode. If you're interested in joining one of the best Android teams out there, please follow the link in the show notes and go ahead and tell them that I sent you. Looking forward to hearing from you soon.
That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.